Okay, let's get looking at the last few questions here. Okay. According to the World Bank, at the end of 2013, the US population was 316 million and was increased according to the following model. Okay. PT defined as 316 exponential of 0.0074 times t, where p is measured in millions of people and t is measured in years after 2013. So t is 0, it's the end of 2013. What will the population be in 2020? Well, what start or end of 2020? I hate when questions are ambiguous. Let's go with the end of 2020. I don't know. I guess it's an odd question. I can see if the answer's right. This is 333 million. Yeah, that's correct. Okay. Determine when the US population will be twice what it was in 2013. Again, assuming the end of 2013. So when will PT equal 2 times P0? And we want to solve, now let's see, I hope we can solve this exponential. Whoa. It's giving me imaginary answers. That's weird. I mean, yeah, I understand why, but I don't need all these imaginary answers. Yeah, I take the last one, I suppose. In 93 years. So answer at the back says 94 years. Yeah, rounded up 94. Okay, so that's fine. All right, next one now. 306. The amount accumulated in $1,000 invested for 2 years and average force model by the okay. AT is 1,000 times 1.04 power t. 5 and 10 years. And then how long for it to triple? And so AT equals 3 times A0. Then we want to solve percent O4. Didn't like solving that. That's so weird. Why don't you like solving that? It's not that difficult to solve. I really don't get why Maxima is sometimes so fussy about things. Let's fall back to derive. So we're just trying to solve this rather simple equation though. 26 power t equals 3 times 25 power t. Solve expressions. And there we go. About 28 years. Oh, did it solve it? No, thought it did. Yeah, if you type in E28, yeah, that's about 3,000. There we go. Okay. 307. A bacterial colony grown in lab snow double in number in 12 hours. Suppose initially there are 1,000 bacteria. Use this exponential function to determine the value of K, which is the growth rate of bacteria around 4 decimal places. Okay, so double in 12 hours. So you start off with 4,000 equals 1,000 times exponential 12K. So that's the equation we're trying to solve for. Okay, let's solve that. Okay, it's this one here. So 0.1155. Is it double or why did I put in 4,000? Well, yeah, why did I put in 4,000? That's so weird. So weird. Why did I type 4,000? Like I doubled it in my head twice. 0.0578. Is that right? Yeah. And then how long to get 200,000? Okay, so we have 200,000 equals 1,000 times exponential. And then I'll use the full number, percent 04 times t. And then I want to solve that last one. Percent 04 for t. Oh, wrong. Oh. Okay, I thought it would take the number. I guess not. No, wait, hang on. That should be percent 03. Yeah. Parson output. Slow. Very, very slow. It's just so weird that like this like tiny like 10 megabyte, I don't know, it's not even 10 megabytes, it's like 1 megabyte program can be so much quicker. Like by the time I can solve this. Oh, I don't think it likes the space there. Okay. Yeah, see how much quicker that is. About 92 hours. And it's still calculating. Wow. Wow. Okay. 92 hours is the answer. Okay, I can't. Okay, Maxima, you really disappointed me. I'm going to finish this exercise off using derive. Okay, the route population on a game reserve doubles every 6 months. Phosphorus 120. Use that to determine the growth rate constant A, round to 4 decimal places. Okay, so you've got, I'm going to use T as months. So you got 120. It doubles every 6 months. So 240 equals 120 times A power 6. Solve expression for A. I don't need the complex answers, you know. Solve expression reals. Okay. And we'll take the positive one. Term the approximately how long it takes for our population to reach 500. Okay, so let me just edit that. And then now we want it to reach 3,500. Equal 120 times A, which is line 14, power T. Solve expression. Let's go numerical. 29 months. Okay. 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 And lastly, the 1906 earthquake at San Francisco had a magnitude 8.3 on a Richter scale. At the same time, in Japan, an earthquake magnitude 4.9 caused only minor damage. Approximately how much more energy was released by the San Francisco earthquake than by the Japanese one? Okay, I'm gonna have to get the Richter scale formula. Okay, consider one earthquake where R1 is bigger than R2. So, okay, so log base 10. Okay, how do I do base 10? Let me just test this out if this is base 10. Yeah, that's base 10. Okay, so that ratio, I'll just write R for ratio, log base 10, that's equal to the difference in the Richter scale. It's 4.9 and 8.3. And it'll be a negative number because the R1 should be bigger. Okay. So I want to solve this expression for R. I wonder if that's a typo. Did I ever type it in backwards? Ugh, did. Just not with it right now. Apologies. Okay. Why did I do that? I must have thought R2 was the stronger one. Okay. Right. 2,522. Sorry, 2,512. Okay. Yeah, that's how many times greater it was. Okay. Right, sorry, not with it the last couple of days. But anyways, that's now successfully completed a chapter. What's up next now? Limits. Fantastic. Okay, so we'll wrap it up there. Any mistakes or problems or anything like that, please let me know. Thanks for watching, and as always, I'll see you next time.